Within Dynamo for Revit and Dynamo Sandbox, users can define custom functionality using special components called CustomNodes. In this lesson, we are going to create a custom node for retrieving room elements by their associated room number. Let's start by opening the advanced Revit sample model that is included with Revit. This file can be found under File, Open, Sample Files. This model is a nice one to use for this example because it comes with every Revit installation and has room elements already defined within it. If for some reason you don't have access to this file on your machine, it will be included in the dataset as well. We'll click Open. Once we have this file open, we'll navigate to the Manage tab and open Dynamo. Once we are in Dynamo, we'll go ahead and open the sample file included with this dataset titled CustomNodes. As you can see, this Dynamo graph is collecting rooms in our Revit model, getting their number with the getParameterValueByName node, and initializing an object called a dictionary. In this example, we're using the getParameterValueByName node instead of the out-of-the-box room number node because it is a bit more flexible. For reference, the room number node can be found under Revit, Elements, Room, and we'll see a node called room number. This node will retrieve the room number as well, but a fundamental understanding of the getParameterValueByName node is very important as you learn Dynamo. Dictionary objects are special because they allow us to define a container to store data with a related value to retrieve it by. Dynamo nodes that interact with dictionaries can be found in the library under the dictionary category. And we can scroll and see this category in our library. In this specific example, we're using the node dictionary.byKeysValues to define the dictionary, and we're using the node dictionary.valueAtKey to retrieve the room from the dictionary given the room number. In our case, our objects are our room elements collected from our Revit model, and our keys are our room numbers that we're obtaining through the getParameterValueByName node. Beyond this example, you can utilize dictionaries in a whole lot of other ways as well. With this workflow in mind, we'd like to turn it into a custom node that allows us to be able to share it in an easier way. To create a custom node, we have a few options to choose from. We can navigate to File, New, Custom Node to create a custom node, or we can do it with a slightly more automated feature in the graph. The secondary method is achieved by allowing us to select the nodes that we want to convert to custom and converting them on the fly in the Dynamo graph. We will utilize that option for this example. To get started with this conversion, we need to select the nodes that are to be added to the new custom node. In the current workspace, let's select all the nodes except for this code block in the lower right corner. This would be an input that we need, so we'll go ahead and remove this node. From here, we can go ahead and select all of the nodes on the canvas, right-click on a blank spot in the canvas, and we'll see that Create Custom Node is an option for us. Clicking on Create Custom Node will launch a new menu that we have not quite yet seen. This window requires some additional information about the custom node in order for it to be used. The first input is our name of our custom node. As a best practice, we should avoid using any spaces in this name and provide as much detail as we can while keeping it simple. In our case, we will name this custom node getRoomByNumber. This name has no spaces in it, and it describes what the node is trying to achieve. You will also notice that I capitalized the first letter of each word. This is a coding standard referred to as camel case and is very useful for defining variables and eliminating spaces within your text. Next, we need to describe what our node is doing. For this example, we can type this node will retrieve a Revit room given its number. This allows the user to hover over the node and receive a description of what it is doing. The last field in our form is for the category in the library that will appear under a category called add-ons. In our case, we can go ahead and name this to start to organize it, and we can view this after we create the node. Organizing nodes for easy navigation is very important and should always be considered. In order to define categories, Dynamo uses a dot separator between the applicable categories. As you may remember, we often navigate the library by first going to Revit, Selection, and so on. In this case, we can mimic this organization. We will type my first node dot Revit, since this node interacts with Revit, collection, since we are actually collecting something from our Revit model. This will allow us to control where the node appears under the add-ons category that we will see shortly. With all of these inputs fulfilled, we'll go ahead and click OK. Once we click OK, we will notice that the selected nodes are now converted to a custom node, which also opened in a new tab at the top of the screen. Additionally, you will notice that we have a new add-ons category with a category titled My First Node showing up. If we expand this category, we can see that our categories now show up that we typed in our custom node. In order to edit this custom node, you can either double-click on the node or click on the tab that appeared on the top of the screen. For now, we'll double-click on the custom node. Once we're within this custom node environment, you'll notice that the background turns yellow. This is to indicate that you are in a custom node. That way you can know what environment you're in depending on your scenario. You may also notice that this enables us to have a home workspace open as well as a custom node workspace. Navigating back to the home workspace or the default Dynamo file, we'll notice that we don't have any inputs in this node quite yet. So we need to fix this so that way our users can interact with our node. And we can navigate back to the custom node to see this. As you might notice, we received an additional node in our custom node called output. This is a specific node to the custom node environment that we're able to use to be able to define custom nodes. An additional one that shows up in our library under input would be an input node. So we'll navigate to input, basic, input. This node allows us to define inputs for our custom node. Let's go ahead and place one of these now. Another thing to keep in mind is your inputs will always be ordered based on the order of creation. So in the case of the getParameterValueByName node, we'll notice that element is first and parameter name is second. In a custom node, we would organize those in order of creation. In order to define an input, we need to name the input value in the input node. In our case, we're looking for a room number. So we can type room number and click outside of the node, and we can connect this node's output into the key value. With this connected, let's navigate back to the Dynamo file on the home workspace, and we can select the tab to do this. As you can see, typing in that input node allows us to now have an input within our custom node. Let's go ahead and double click to navigate back to the custom node to continue editing it. One thing that we want to change is this output value to be named something that's a little more specific. As you can see, this value is the default name. We can go ahead and double click within this node and modify this to say room. This allows us to tell our users what we're returning to them from the node. In addition to allowing us to have inputs and outputs, these nodes allow for additional functionality. Within the input node, we can specify a tooltip for our user to better indicate what we are needing for this value. In order to do this, we can click inside of the input node, press enter to add a new line, and on the top line we can type / and a description of what our input is expecting. In our case, we're looking for the room number to look up a room by. Click outside of the custom node and we'll go ahead and hit save now. So we'll hit save on the ribbon. Once we hit save, we'll notice that we're presented with a file browser. By default, Dynamo will save the custom nodes in a definitions folder in your user app data folder. This allows it to be loaded into the Dynamo library. Let's go ahead and hit save. With that saved, you'll notice that we now have a DYF file extension on the tab. If we navigate back to the home workspace, copy this node, and see that we have some values update. I achieved this through a control copy. This allowed us to refresh the node and see those changes that we made. I'll go ahead and remove the original version now. With this node placed, if we hover over the input port, we'll notice that we now have a tooltip. This is really nice because now a user can start to realize how they need to use the node. We can double click to continue editing this custom node. In addition to tooltips, input nodes allow you to define the value that the user needs to provide. Remember, I mentioned earlier that a room number is a string value or text. So in order to allow us to always expect that kind of data, we can define that in the input. So after the room number variable, I'll type space, colon, space, string with a lowercase s, and click outside of the input node. With that value added to the input node, we'll notice that we now have a purple series of text. This is because we're now defining the data type that we expect to be input into this CustomNodes input. We'll go ahead and hit save and navigate back to the home workspace. Now, if we hover over our custom node, we'll notice that it says string. This is telling the user what kind of data we need to input into this custom node to be able to make it work. To test this node out, we can go ahead and double click for a code block and type in quote 100 end quote, click outside of the code block, and now we can tie this into the node's input. If we hover and pin, we'll notice that we're receiving a value of null if we type in 100. If you change this value to 101, you'll see that a room element is returned to you. This node's powerful because it will try to find the room. If it can't find it, it will return a null value. This allows you to do filtering and things like that down the line. To have a little bit more fun with this, let's double click for another code block and use a range expression. In our case, we'll type 101.120 to indicate that we need a series of numbers from 101 to 120. We'll double click outside of the code block. We'll notice that we have a list of numbers. If I were to plug this right into the room number, it's going to tell us that it expects to get a string element. So we need to convert this list to a string first. The easiest way of doing this is to search the library for a string from object node. This node is special because it allows us to convert pretty much anything into a string or text value. We'll place this node now. For the input of the string from object node, we want to connect the range expression from the code block, and then we'll connect the output into the room number. As you can see, our custom node has ran and retrieved all of those rooms that relate to the room numbers. In this case, all of the rooms were found in that dictionary except for the one at index 12. Index 12 would be room 113. So it appears that this model does not have a room 113. These kind of operations are really useful for when you need to retrieve data from the Revit model in a very specific way. You can use this kind of workflow for anything from room names or element names and beyond. As you can see, the combination of dictionary nodes and custom nodes in Dynamo can prove to be very powerful. An understanding of both of these topics allow you to create a more robust Dynamo definition for your everyday use.